Hello everybody, this is Avantik here. Today we'll try to develop a project, end-to-end project which will include your web application side and a deep learning side. What we'll do here, there will be a form in the web application here, web page here. Anybody can upload any image. Maybe you take a photograph of some object. You upload your image. What it will respond is, when you upload the image, what you will get out of it is, it will tell you what it is. So for example, you take up your pet's photo and upload it over. It might tell you it is a dog or a cat, whatever is it. And it might give you more details, like I have a pug at home. If I upload pug's photo, its photo, it will tell that it's a pug. That's the thing we'll do here. Let's get started. First, we'll list down all the dependencies over here. The first thing is we need Anaconda 3.6 to be installed. With Python version 3.6. Anaconda Python version 3.6. You get all your machine learning libraries here. Next, what we want is, we want Keras to be installed. This is for the deep learning part, which based on the image, it will identify what it is. Keras. Pip install Keras. And please don't forget this line. Always use pip of Anaconda here. Pip install Keras. Then we want Keras to be internally using TensorFlow, so do pip install TensorFlow. So pip is for installing Python packages. You're installing Keras, and the last thing is install Django. Django is web framework based upon Python. So using this, we'll be developing the front end side of it. We'll be using Keras in the back end to actually do the prediction. This is the entire plan here. Let's get started with our app creation. Django admin start project. My web app. This is what we will create a Django project. If you list down it over here, you can see this my web app. We want to really see it running. Then do Python manage py run server. It will actually run the web server. Let's see. So let's first open it out. So it's localhost 8000. That's what is doing it. So you have a default Django application ready now. That's the first stage. So you have your web application ready. We can stop it here. So that we can proceed developing more things on top of it. Let's open the project. So I'm using Sublime Text here. So what I can do is open folder. Go to the directory, my web app. This is the application, right? If I open it here, this is all I have. You can see here, you have the settings py. This is the configuration file here. And you have a URL py. It does all the routing and everything. So what is the next thing that we'll do here? We'll create an app inside this web application. It's like a module. And we'll add all our features over there. If you list down here, we'll see it, my image upload directory getting created. Let's see it. What are the things that it brings to the table? You can see here, you have this image upload directory getting created here. Now what we want to do is, we want to show some web page which is different from the default page. To do so, we have to create a template directory, and we'll put all our HTML files over there. New folder, templates. Let's create two things. New file. You have here templates. One is your home.html. Just mention here things. My home. This is my page. Save it over here. So it is present inside your templates. So whenever you create your template directory where you have all these HTML pages, don't forget to mention it in your settings.py. This is the place where you'll do it. Templates. Save it. Fine. So you have it over here. Now you go to the URLs. Here I want to redirect some of the URLs to my this image upload app. So what will you do for that? URL image Okay, include is not yet imported over here. Include, then mention it image img upload dot urls. You want it to redirect to that, and don't forget to put comma over here. Okay, so you have it over here, then you go here, then it is importing this. You don't have a urls.py here. Okay, so make one urls.py, new file, save urls.py. Okay, once this is created, you can copy some of the contents from here. Of course, your admin and those things is not required over here. So first thing is, you want, if somebody reaches here, views.home. Okay, and this is the function that it will execute from dot import views, right? And you can see here you have this views file here, which is currently holding nothing. Okay, let's now write a function here, def home requests. Okay, then you can do render return render requests. Okay, so let's see what we are doing here. We are importing, what we are doing, we are creating function home, which is the one that will be executed when somebody tries to access this particular URL, home, views.home. You're creating this views.home here, and here you are mentioning home.html. Okay, that's pretty much that you're doing here. Okay, so let's see if we have missed out something. Things look fine so far. And if we run the web server here, if you're missing out on something, this guy will tell us. And yes, one thing we missed out. In settings, whenever we have added one app, right, what I have to do here is we have to mention it over here. Okay, img_plod. Okay, and once you do that, okay, so it will tell you that some migrations are missing. It's okay, we haven't added anything to database. Let's see the server now. Okay, we're getting this thing. It needs image upload over here because that's the URL we have created. image upload. Okay, so you can see this page completed. So you have a Django application where you have added one page. The next thing that we'll do in our next video is connecting a form to that where we can upload that image. Okay, so this is the first part of it. Thank you. See you in the next video. Hello everybody, welcome back. Okay, last video what we did is we learned the dependencies, we understood what we are trying to do, and we created a simple Django project without adding any piece of code over anywhere. Okay, that is all we did. Now in this video, we'll not add on the Django side anything, we'll create our backend. What we'll do is, okay, we'll use a pre-trained deep learning model. I'll discuss about those things. Let's come step by step. First, what you can do is open this page, Kira's io.application, as you see in my URL. Okay, this is the page. So you can see here a long list of pre-trained models. Now what are these pre-trained models? And these are image trained models. Okay, that means you have trained here for a lot of images. So all of these, and we'll be seeing this ResNet 50. Okay, all of these are trained with ImageNet dataset. Okay, it has 36,000 types of images. That means it is capable of identifying from 36,000 images. Okay, you can search for what are the things ImageNet is capable of. Just search for ImageNet classes. Okay, you'll find a list which you can see this. Okay, so it is capable of this long list, right from goldfish to house finch to bulbul to kite, bullfrog. Name it, you have a huge list here. Okay, you can take up this URL for more details. Okay, so this is trained with these images. What it means is it is already pre-trained. The training, the model creation part, all those things have already happened. What we intend to do now, use that pre-trained model, connect it with our Django application, upload image in our Django application, use this pre-trained model to the prediction and show up in the result. Pretty much that. Let's see. Okay, so this is what. So let's see how to use it, and for that you don't actually have to go anywhere, just in this part of it. So you can see here ResNet is there. So all we can do is we can make use of this code. Okay, so this is the URL. Okay, what you can do is just copy this code after you have installed Keras. That is the point here. Okay, so what you do is here backend test. That's what we are trying to do now. Okay, let's include all the dependencies. It may take a little while depending on your computation powerful laptop because it is trying to install something. Okay, it might take a little while. Okay, and you can see here it shares TensorFlow in the backend. That means Keras is a high-level deep learning library. It uses TensorFlow in the backend. Of course, it can use any other library. CNTK is another library by Google. It can use MXNet, right? It can connect. So it has become a de facto for anybody writing deep learning application. It's really easy to write. Okay, and the complexity is abstracted. Here the star sign shows it that it is still computation. So let's wait. Yeah. Okay. It might take a little time based on your system, but wait till the star goes away. So what we have now, we have all the things imported. Okay, now let's get to the next stage. Okay, what you're doing, this is a pretty important line. You are actually getting that model. This is the model. Using that you will be doing the prediction. This is the model. This is the pre-trained model that we are trying to get. Okay, and here we are mentioning weights is equal to ImageNet, telling we have trained it for ImageNet. Okay, just execute this. It might take a little time as well. Okay, till the time what we'll do is we'll try to download some animals image which we want to detect. Okay, so what will I do? I have few images in my system, or you can of course Google it. Let's Google it. See, it mentioned that it is trying to download and it may take this file. It will of course reduce that a bit. So what you can do is, okay, so let's see here, just search for elephant or teddy bear. Say pug, right? Let's search. If you're a dog fan, you definitely love pug. Let's see. Okay, so maybe we really want to search this guy. Okay, let's save this photo. Okay, so in pictures, pug. Okay, so that's the whole idea. Now let it finish. It's about to. As soon as the star goes away, it tells you it is done. Let's see. Yeah, we can see now that it is gone. It has finished now. So let's choose the animal that we want to. So here they have done with elephant. Okay, of course you can name it anything. I have a pug here. It's in my pictures. It's not giving me the full path. So what I can do is properties pug.jpg, right? Okay, we want to see the image. What you can do is import matplotlib.pyplot as plt percentage. Okay, this will make sure that you can see it here. Okay, then let's load the image, and from skimage.io import, just to see the data and all that, import imread. Okay, you can see the image. Okay, as we understand, image is actually internally all the numbers. Each pixel of an image is represented by RGB. Just a brief around image, and you can see this is the image details. Okay, you can see all the values of RGB. We don't have to deal a lot around it. Just mention here image is equal to this. Okay, and if you want to see the image, plt.im show. Okay, if you do this here, it will show. So this is the thing. Okay, so now what we want to do is we want to do some prediction around it. Okay, again let's get back here. Okay, this is basically image load and you're trying to predict. Let's execute it here. Yeah, it's done. So if you do preds, okay, you can see some information which is not making a lot of sense here, right? We want to interpret this information. So what we can do is you can use this line, decode prediction is the API, and we do this. Okay, it will make a lot of sense now. It will tell you which class of it is. So you can see here it is executing. Okay, and you get the result here. See, with 81% accuracy, it has identified this image as pug. How amazing it is, right? With just writing less than 10 lines of code here. Okay, so that's the whole deal. What we'll try to do, we'll create a web interface where we'll upload an image and it will give you this output. That's the whole drill around it. I hope you got my point. Thank you. See you in the next video. So I have changed the text a bit. This is the image upload page, and here I intend to add a form here. You can see method post. I mean, this is the form, and this is the action means this is the URL to which the submission will go. Okay, then you have a method. Method is post here. Okay, so that's what this is post message, form submission, and kept type is multi-part and form data. Okay, this is, you have to make sure you write this, because how form data is handled is actually broken into chunks and it will be handled in the server in that way. Okay, so in kept type, multi-part, form data. Action, this is the URL. So let's see the URL. So now image upload is a base URL. Okay, and image upload, and inside this we have to write a URL here. So let's see URL image process. Okay, so what we have is image process. Okay, so you have this URLs which goes from image upload to image process. Okay, so here it will be image upload to image process, and you can see here this field. This is a field whose name is ID is image, uploading a file, and the submit button. Okay, so after doing these changes, let's see, and in the views thing we have to have a function image process, def image process result.html. okay, so this is the function. So we have to have another HTML page over here, new file, result.html. result page. This is the view. Okay, so on form submission we should actually see this. We are not yet saving the file on form submission. All we are doing is user will submit and he will go to that page, image process. Let's see if the entire route is fine. Image process. Okay, so it seems Django has reacted well to that. Let's see if our web application is fine. If we do this, it should show up a form now. Yes, it is showing up. Okay, if we choose anything, like I'm taking this photo, open, submit. Okay, it is going here. So the paging infrastructure is fine. All we need to do now is what the file that is being uploaded over here, right? We need to save it so that the Keras or deep learning application can process it. So let's come here. So this is the space where we should be saving it. So what we need to do now is, this is the function which will actually handle the broken parts of the file, handle uploaded file. It will save the file as image.jpg, and this will be the place destination. Okay, that means this is creating a file image.jpg. Destination is a file handler, and what you're trying to do, you will be saving this file using this function. This will be the file pointer, and in here, if first we have to create a form file, new file, forms.py. okay, this is the file here. Okay, so that's what we are doing here. We are creating Django form import forms. This is the file image field. Okay, and in the views, chop this part as well. Okay, resume from here. So we have it. This is the form that we have, and make sure you import this guy from dot forms import image upload form. Okay, you have this image upload form over here. Form is valid and you are letting it handle over here, right? Image. So form is valid, and this, remember the field name was image over here, right? That's why I'm taking this. Okay, so if everything is all right, what should happen, whatever image I'm uploading, I should see here image directory. Everything is all right. Okay, that is the first checkpoint that we have. So it seems this guy is not happy with me. You can see here indentation error, it is complaining. So what you have to do here, select all. You can see this lines over here. You can do view, indentation, this guy, save. Yeah, now it's all fine. So let's come to this application. Okay, let's refresh this page. Let's open the image, submit it. It goes to this page, flow is correct. Let's see if the content is there. You can see here image.jpg. So what happened from the client side, on the browser side, you are uploading the image and that is getting saved in the server in the name of image.jpg. Okay, so that was the objective out of this video. Okay, so next what we'll do, we'll now write the deep learning part of it. Okay, that means and using Anaconda we'll be writing deep learning part. We'll use the pre-trained model. Then we'll integrate the deep learning part with this application. Okay, Thank you. Hello everybody. So let's welcome to the final stages. What we will do here, we have a Django application which has forms ready. What we'll do now is we have a backend where the pre-trained models are ready. We'll try to connect them both. Okay. So the first thing is we need to import the libraries that is required for adding deep learning functionality over here. Okay. So we'll refer to our previous stuff. Copy paste this guys. Copy it over here. Okay, so all the libraries that is required for this is added. Now you want to add the functionality over here. First thing that you need to do is create the model, right? This is the model which gets created. Remember, it's a pre-trained model. It takes time to load this. Okay, pre-trained model. Now, and we have the image. Our image is this guy, image.jpg. Okay, so img is equal to img.jpg. Then we need to set the image path. Okay, so image path, actually img path. Then what we need to do is load this pre-process input, and this is the prediction here, and this is the outcome that is to do. Okay, so let's see this here. Okay, decode predictions. You have the predictions here. Let's save it. Okay, now what should be the stage? We should be able to upload an image and it should give us the outcome. Okay, in the backend, since we are doing a print here. Let's see if this functionality is intact. Let's run the server. It might take some time to load it up. Okay, things look good. So now let's get back to this page. Refresh this, choose the file, submit. It will do the processing. Let's check the backend. This is where we should get some acknowledgement how things are going. Yeah, we can see it getting detected. Okay, so that's the stage. Okay, we know that the integration has gone well. Now we want this output in the front end as well. Let's see. Okay, so and you can see here there are in the back end there are three accuracies. That is, this is a pug, this is one accuracy, bluff mastiff, and French bulldog. There is three things, but of course you can see this, the confidence level here is 15%. It's in fact 0.1, less than 10%, less than 1%. Okay, so here it's more or less pug. Okay, but we still want this three output to be shown in the web page. Okay, showing all the possibilities and the ratios. Okay, so in the results page, this is okay. So this is what we do here. You can see here we have a loop here and the rest thing here. Rest thing is giving you two things. One is R, one is P. R is your type of the object type, and this is the percentage. Okay, so this is the templating in Django. You can see this is looping through all the contents because we'll be passing three contents from the backend. Save this in the rest page. In the views, okay, so in here, okay, just do this HTML is equal to, this is giving you three contents out of it. Okay, so what you're doing next is we're actually just adding the contents in the rest directory, and it contains the name of the species and the percentage. Okay, and here after this is done, return render request result .html. Okay, so request, yeah, cool. So this is what it will upload now. Okay, let's restart our server and see if things are fine. Control C to restart. Sometimes it gets stuck, so you might have to press it multiple times. Let's restart the server. Seems good so far. So this is giving you three fields, the pug and the percentage, the next element and the percentage. You're just putting it in a list over here. Okay, as a tuple, the pug and the percentage, the other animal and the percentage, and so on. That's a list, 3-element list. Okay, and this is what you are rendering into this page. Oh, but okay, so here you see result stuff. It is using this res field. So actually, in the views, I have in the res save it. Okay, so let it load. Yeah, it loaded. So let's check this page out. Okay. Okay, come on. Submit. Okay, this is my PEX photo. You can just Google it, or take any photographs and upload it. It will work seamlessly. Okay. Okay, it's taking some time. Okay, that's precisely because I'm running in a low-end machine. These applications are usually running in a high-end servers. Okay, this is what the first part of loading is done. Okay, so what we see is the result page. It's printing it here, but it is going not to the result page. Okay, just will fix this thing here. Okay, it has to be from this HTML to this guy. Okay, yeah, so let's now add this stuff over here. Okay, so what we have the outcome of this. We are adding it over here, and this is the details. Okay, save it, run the web server again. Okay, so let's come here, choose file, pug, submit. Okay, let's wait for it. Okay, so in case you get this error, template does not exist. Results.html does not exist. Let's check it out. My web app, results.html. As you can see, it is result.html, not s. Save it. Okay, so we now need to restart the server. Okay, this template does not exist, means the HTML path that you have mentioned, there is some path finding issues. Let's see. Choose the file, pug, submit. Okay, so yeah, so we are getting this output over here. Okay, so now what we need to do is we need to add this template part of it. Okay, choose the file, that's the one, submit it. It's still processing. Yeah, we can see here pug is 81%. So based on image that you're uploading, it is identifying pug as 81%.54. Okay, so just feel free to play with this application. Download any image from Google, choice of your interest, upload it over and it will tell you what it is. You can make fancy apps with that. Yeah, thank you. Thanks everybody. Take care. Bye bye. Hello everybody, this is Avantik here. Now this is a series about executing deep learning. Okay, enough learning through different MOOC or different study materials. Unless you do it, see it, what you have studied is true and relevant, it won't make sense to you at all. Oh, so this entire drill is about that. I'll be running this entire training of the models in AWS GPUs. Okay, so you can of course choose for other options as well. I just use it in this case. Okay, let's get started and let's discuss with the problem statement first. As you can see in my screen, that's one of our favorite dog, Gullu. Okay, now I'll go through several training stages of dog breed prediction. We have data set which consists of 120 breeds of dogs of over 10k plus images. Okay, so I'll train it and I'll see at various stages what are the top 5 prediction that it makes. Okay, or top 3 prediction that it makes, and see how close can we get to this. Okay, so okay, let's get started. Okay, so this is the data set can be found here. Kaggle breed, dog breed identification. Thanks to Kaggle for making it open to everybody. We have used the data set. You can get hold of that. And there is a labels.csv file. Okay, so this is how it looks like. Okay, you can see this is some ID and this is the breed of the ID. Okay, so and if you want to see how the data looks like this. These are like different dogs here, and this is the ID. So you have a ID to breed mapping file, and you have the data. Okay, this is what we got now. Let's understand step by step, and we'll use VGG 19 as a pre-trained model. You can use others as well, but just that this trained model has a lot of breed of dogs getting trained with. I mean, it is trained for that. It is using imaginary data set, so it has quite a few dog breeds. Okay, but not of course 120, and this is specially for dog breed identification. It is not generalized that the imaginary data set is. Okay, so as we can see here, we are using Kira's image library to do the image pre-processing part. Okay, and sklearn library we are using for label encoding part. You can use otherwise as well, but this is what we have been using. We are using matplotlib for visualization, and Keras has a way or handler to take callback functions. Okay, this is early stopping is one of them. So that is what Keras is doing here. Now let's see. Okay, so initially what you have to do is you have to get the data right so that we can do the training and all this stuff. So we have this labels.csv file. This is what it looks like. We have ID and breed. Okay, and you have the training images here, and the files. This contains the name of all the images. Okay, that means the ID, the name of the file is the ID that is mapped here. So this contains the name of the images. Okay. So what we are doing, what you are trying to do here, this is one point we need to take, consider when you are, this is AWS Linux. So the ordering won't be same as Windows. Okay, so you have to make sure the order in which the files are kept in the directory. Okay, what I mean by that is this. Right, the order in which we know the breed mapping. So we should do based on this ID, not directly. Okay, so for that we are you are merging it based on ID. So this is the ID of the files. Okay, in the order. Okay, this is the file, and this is the ID of the breed. You can see the order is different. So we need to merge it based on ID, and that's what we did here. Okay, at the end of merging, this is the ID of the file, and this is the breed. Okay, that's the mapping we have now. We basically would use read of matplotlib library to actually read the data and read the image and convert it into NumPy. And of course, we can use it to see here. This is one of the photo that is present in my training data set. Remember, Gullu is not there in my training data set. Okay, that's our favorite dog, Gullu. Okay, it's not there in the training data set. And I think folks who already know and dog lovers who know this is a Labrador. Okay, and we'll see, and it has quite similarities with golden retriever also. We'll get to that. Why I'm saying all those. Let's see. So we have the data ready. We have the mapping information. Then that means this is what it is. This is the ID of the file. This is the breed. Okay. So what is the first thing that you need to do? You need to convert this ID into the contents of the image. So for that, what we have to do is we need to this is one thing that we have to convert images to NumPy array. Okay, basically we need, this is 10,222 images, and each image we are reshaping it to 224 cross 3. That's because VGG wants that by default. Okay, we can use others also, but that is the default thing for VGG. So that's what we will be doing. 224 3 and 10,222 images. So you can imagine 10k images stacked over each other. That's what. Okay, and when you're in the neural network world, your output should be the target should be as one hot vector. So we have 120 breeds of dogs class here. Okay, dogs breed here. Let's see. So label info breed unique. This is giving me 120. So we know that the training data has 120 breeds of dog. Okay, so that's what. So we are using label encoder to convert this into number, and then you are using toCategorical to convert each number into vector. Okay, each number into vector. Like there are 120 classes, right? So you will be representing that as a one hot vector, 120 of size. So that's why the output becomes 10k comma 120, because each class will be representing one hot in that 120 bits. The rest of them will be cold, that is 0. Okay, so I believe, just a recap here, how the training data would look now. The train feature data would look like this. Okay, the target data would look like this. Now, certain callbacks and registration. So this is one callback that we'll be using, early stop, and it's pretty useful in production, because you cannot keep on running training model as long as possible. You need to configure it so that with some patience level. Okay, patience level. We are creating an early stop here. What happens by this is, if the model stop converging, because of this guy, the execution will stop. Okay, and you can mention how many iterations if the model does not converge. Okay, if it is 2, that means first time it reaches 2 times the same value of certain loss or accuracy, will stop over there. Okay, so now that we are ready with the data creation part, from files we actually convert into numpy, we from labels we convert into a vector. Okay, then one hot encoder, like time to basically create the model now. And as we discussed earlier, we'll be using VGG19 here. Okay, you can give it a shot with other models as well. I'm using VGG19 because of limited layers here. Okay, and the good results it has shown in the past. Okay, so we'll be using that, and in the first attempt, what will I do is, I'll just get the model. Okay, this is a pre-trained model, that means you have weights and it's all trained for you. Okay, I want to just remove the last layer, because last layer is trying to identify more complex information. In this case, it was trying to identify one of those 1000 classes. Okay, I am stripping that out by mentioning it here, include top is equal to false. Okay, now post that, what you're doing here is, we are actually, after this, we are trying to create a next layer. Okay, and the next layer consists of something known as global average polling 2D. Let me explain what it means. Okay, this is not my diagram. I got it from internet, and okay, thanks to folks who created this. Okay, so what is this global average polling? So before this layer, it is all playing with the same spatial dimension, like means the data, the image, right? It has some spatial dimension, so height, width, and depth is there. So what this global average polling tool is, it actually prevents overfitting by reducing the content. As you can see here, rather than height and width, it just retained the depth part of it and made it one dimensional. That is what your global average polling 2D does. It actually prevents overfitting. It converts your data from this format to this format. Okay, that's what it is doing, and you are basically connecting it to the output of the current whatever state you have. You are connecting it to that global average. Then you have a dropout. Dropout will actually further reduce 20% of the neurons from learning the parameter, learning the weights. Okay, that's what it is doing. This will prevent overfitting the last layers. Okay, and number of classes that you are trying to identify is 20, and you are basically doing a multi-class classification, so it's softmax. Okay, this is the layer that got created now. Now we need to integrate this layer with the train model. We created the layer using the configuration of the previous information. Now we need to do the integration, and this integration part is actually done by this function model. Okay, as you can see here, this is the one which is doing the integration. This is the input output. Okay, and what you're doing here, you intend to train only the last layer, not any other layers. Okay, that's why you're doing this layer VGG model dot layers and layer dot trainable is equal to false. Precisely, you are making all other layers non-trainable. Okay, and when you are compiling it, model.compile, you have to mention categorical cross entropy because it is multi-class classification. Optimizer, we is using Atom optimizer here. Okay, of course, there is a decision making that you do. You can try SGD and other thing, but VGG19 works well with this. We can refer research papers for that. And you have matrices, and we are using accuracy. So once you execute this, it dumps your model like this. Okay, these are all the pre-trained here which won't be trained. The only trainable parameters is this 61,560 parameters. Got it, right? So you just made one layer trainable, and this is what it is. Rest of the layers is non-trainable. As we increase the number of trainable layers, we'll see it, this parameter getting increased, and it will take more and more time to converge. It might overfit also. Okay. So it takes a lot of time, and I'm using AWS GPUs to train it. It's taking a lot of time. Okay, and what we see here, we have trained the model with 20 epochs, 256 images gets taken at a time, and the validation split is 20%. That means after training with 80%, it will test with it will validate it with rest 20% and give you this validation accuracy. Okay, and this is the callback function. Verbose 2 means it will show some of the displayed information. So that's what we started with. There's two things here: accuracy and validation accuracy. Accuracy is training data accuracy, which is definitely some indicator how the training is going on. But validation accuracy is the verdict. Okay, that means this is the one that is showing for untrained data. That's what it is doing. Okay, so every time it is splitting the data into 80-20. 80 it is used for training, 20 it is used for validating it, and it did till 20 epochs, and we can see here the validation accuracy is some 61%. Okay, so of course, one thing more, that when you are doing the training, make sure you store this in a variable, or this information will not be available to you. Okay, it will just dump it here. So that's what we did here. This is a dictionary here, so that's why we can do keys, and you will find all the things: validation loss, validation accuracy, loss, and accuracy. Okay, and if you want validation accuracy, basically I'm getting in the validation accuracy list, and this is the accuracy. So and I'm trying to plot it here, accuracy versus validation accuracy, and this is what it becomes. Okay, so this is my accuracy. We can see it's improving. Okay, the graph is good, but the validation accuracy, it's somehow plateauing it at 60s, right? Early 60s it is plateauing it at. Okay, so I want to basically use this model. Okay, so this is the model which I've saved in this name, model last layer H5. I want to really use this model and see what is its prediction as of now. Okay, so this is last layer trained. I have saved the model, load model. Okay, I'm trying to load this model, and load model is Kira's API. Okay, last. Okay, I'm loading the pre-trained model which I had earlier, and I want to do some prediction. So this is Gullu's image that I've loaded. I've done some basically all the needful conversion that is there. So last layer model. Yeah, let's now load the model and now verify how things are. Okay, so I'm using this. This is what I have done. We've trained only the last layer. Okay, with whatever data set we had. That's it. We are now loading this image, the model, and after loading model, we have Gullu's data already loaded here. The image, it's being pre-processed to the size that we need. So we basically would call the predict function, and we can pass the image data here. Okay, this should return you a result. Remember, the result will be a vector of 120 size, where each value will correspond to the probability of it belonging to that particular class. So we can have top 3, top 5, whatever we have. So this is what it is. So we want to basically see top 5 prediction of it. Okay, what is the situation now? So okay, so this is basically returning a top 5. Okay, so what it is doing here, it is sorting it, getting the last 5. Okay, and this is what it is. So this is the indexes here, right? Now what we want to do is we want to actually see the values, see the names, because this does not make a lot of sense, right? So in the top earlier we used label encoder to convert it, right? So yeah, this was it, LE. So this fit transform is I will use inverse transform to convert it from number to name. Okay, LE dot inverse transform S. So you can see here this is the because of the way arcsort works, right? The last one has highest value, highest similarity. Okay, so this is the first prediction, this is the second prediction, this is the third prediction, this is the fourth prediction, this is the fifth prediction. So it is predicting it as a golden retriever. Okay, whereas Gullu is Labrador, and as of now, I understand there are similarities, and folks who are new to this, okay, golden retriever. Okay, it would also look very much similar to that, but it's a Labrador. I'm not so happy, right? You see here, it has some similarity. Okay, it has some similarity, but okay, this has some similarity, but definitely it's not a golden retriever. I'm not so happy with my training. Time to test more. Okay, of course. Okay, if you want so this graph tells you training accuracy versus validation accuracy. Okay, so it gives some indication here. Okay, and we have trained only the last layer in this case, that is the 61,000. We want to try a little more. We want to try training, couple of more layers. Okay, so let's see. Okay, now that's what we want to do. We want to train two more layers. Yes, okay, couple of more layers. And on changing this, you are making this trainable and this non-trainable. Okay, and on doing so, okay, you increase the number of trainable parameters as 24,21,000. Okay, 21,368. Okay, that's the number of trainable parameters this time. Yes, it's a Herculean task. Okay, but as of you increase the number of trainable parameters, you are getting prone to overfit. Okay, if you don't have sufficient data. So yes, we trained it. It took quite some time, and you can see it converging. Yes, the training accuracy came pretty close to 9.5.95, but the testing validation accuracy is still 60. I really want to see what is the prediction for this guy now. Okay, last 2 layers model, load model. Okay, I'm training, and this is the model for last 2 layers. I can do the rest of the stuff same. Okay, so this is the prediction. This is the this is the output of it, and you can see it pretty close to what was earlier, right? Pretty close, nothing much changed. Okay, so after this, after trying few more trainings, I could still get definitely Labrador as after third or fourth prediction, but not definitely the first prediction. Then what you can do, definitely you don't have infinite images, and this is how you can still train your models with limited data. This is known as image augmentation. What we'll do is, using Keras API or other image augmentation libraries, you can generate images from one image. You can generate many images. For example, if you have a dog, you can actually rotate by 20 degrees and generate more and more images. Okay, so to do so, what we can do is we can make use of image augmentation APIs provided by Keras, and that's what we did. We used image data generated. You can refer more for details. So these are certain parameter which talks about some configuration possibilities of generating new images. So after that, this is the entire data that I had. I actually trained it here. Okay, so with the entire data. Okay, so this is like data generator now. Okay, now it is in like an iterator. It will generate images for you, and if I use the fit generator function, you don't generate image and save. It will generate image, pass to the model, and the model will be trained and it will carry on. So this is like, it will use CPU to generate image, GPU to train the model. That is what it will do. Okay, so that's what we are doing with model fit generator function. Okay, using this model fit generator function, it is training the model. Okay, and we are using the same layers here. Okay, so and we are saving it image augment 5. Okay, same model, just that the data changed here. Okay, only the last layer is different here. So image aug 5. So let's see now what is the prediction for that. I'm changing here to Gulu. Okay, this is the load model, image augment. Okay, model is equal to, so I'm loading the model. Okay, and this is the prediction part. Okay, this is the dump of it, and if I want to do the transformation. Okay, so this is the transformation. I'm happy to see this. At least now I'm getting Labrador as an option, second, but still first one is golden retriever. Still not happy. I want the first option to be Labrador. I love Gulu. Okay, let's see. Now, okay, pretty much same stuff, just adding one more layer to the training. Okay, adding just one more layer. Okay, so now this is 2 layers. I have now a lot of data generated because of image augmentation, and quite a few parameters, 24 lakh. Okay, let's train the model. It took some time. Okay, because your training, I limited it to only 10 layers, and anyway it was not converging beyond the point. Okay, but the great news for me here is, okay, so this was the image data anyway. Model few last year's predict. Okay, this is the prediction, this is the stuff, and when I did a transformation here, okay, it predicted Labrador. Okay, though, and the second option is golden retriever. You can see here, right? It depends a lot on the experiments that you do. You make conclusions out of it. Of course, you can validate. So let me touch upon some other piece of stuff. But got the level of experiments that has happened. You maintain a logbook where, or you maintain whatever training data you have here, right? Whatever training you have, you use this option. This is like, it will store all the training accuracies and all that. Keep it separate. Don't overwrite the content. If you're using GPUs, make sure you run that in background, so as even if your laptop goes off, in the server it continues running. Okay, you should not be repeating experiments. Okay, and in this images and all, you want to know, okay, first prediction is great, but you want to see how accurate is this model for till third prediction. What is the accuracy? So for that, fancy piece of NumPy code here we can do. Okay, so what we can do here, so this is doing the prediction, this is getting till third prediction, and few NumPy fancy stuff here, so that we get if in the third prediction our accuracy is coming correct or not. Okay, so that's what it is happening here, and based on that it is giving you the accuracies. Okay, the code will be available in the link, but you can check that out, and let me know if you have any feedback. So to cut it short, what we did throughout, we got this dog data of there are 120 types of breed that is there, just 10k images. We did some training without augmentation initially. We didn't get good results, though the accuracy, the validation and all that was, I was still not happy with the results. I went ahead and did some image augmentation, trained the model against with that similar model. One was with on last layer learning, one was with last 2 layer training. So with this model, what we got in the last experiment, we are getting good results from some live experiments. Thank you, and see you in the next video with some new projects. Thank you. Hello everybody, this is Avantik here. Welcome to a brand new series of AI project, Fraud Detection. I will try to develop and deploy fraud detection model very similar to production quality. It will have almost all the components. The entire series is divided into 5 modules. First one will be objective. We'll try to understand what are we trying to achieve, what are the infrastructure that is required. Then we'll do all the needful installation. Remember, we are trying to set up everything in our local machine, so we need to have all the components installed and running. Followed by that, we'll do pre-processing of the data, because machine learning algorithms expect that. Then we'll connect try different algorithms. Followed by that, we'll choose the best algorithm, and we'll finally go for deployment. I'm really excited, so let's get started with the series. Thank you guys. Hello everybody, this is Avantik here. Welcome to the first module, understanding the objective of this micro course. Here, we'll try to understand what is credit card frauds, the objective of the course, introduction to Kafka. We'll see, how we are using Kafka here, Cassandra, and finally the solution, the technology, the components that will be integrating it with each other to give us the solution. Right? Let's get started. Let's dig deeper into all the components, the data flow of the entire ecosystem. A credit card company has historical data of credit card transactions. It has the information if the transaction was fraud or not based on some analysis or reports. This is stored in this database, right? As you can see here. After data wrangling and doing simple data analysis, we would like to use machine learning here for creating a model, which can predict whether the transaction will be fraud or not. Once the model is ready, right, we will deploy it. Data for prediction can come from various sources. It can come from all Kafka clients. Assume that Kafka clients are running on the machines or on the first hop of all the machines where a credit card transaction is happening, or via REST interface. Okay, so once this data comes to the model and the model does the prediction. The prediction results and the data is persisted again to some other database. And there will be an analysis over here whether the transaction was fraud or not. And after the analysis was done, this data will be merged back with the historical data, which can again be used for training the model. Okay, so you can see the entire data flow is like this. Okay, now we'll understand Kafka after this. Kafka is a highly scalable distributed streaming platform. It uses PubSub model. Okay, what does it mean? The sender of the message will be sending the message or publishing the message on a topic to which the subscriber or people or entities which wants to receive that particular message, will subscribe to, and they will get those messages. So it's a PubSub model, publisher subscriber model. So credit cards accepting endpoints, like the machine on which credit card is accepted, or first hop of the machine, which is connecting all the credit card accepting machines, uh, acts as a Kafka producer. Okay, they will send data, the transaction details, to Kafka server, and Kafka consumer, where the model will be present, trained model, will be acting as a consumer to that Kafka server, and it will be accepting those transaction messages, and it will do the prediction. So that is how Kafka comes into picture. So if you go back to our previous objective, so one possibility is that the model is getting all the data from Kafka servers. Another possibility is model getting data from the REST interface. So this was about Kafka servers. Cassandra, this is the data store that we are using. If you go back to our diagram, we can assume that our historical data is stored in Cassandra, and all the live prediction data is also getting stored in Cassandra. Cassandra is very suitable for this particular task because it is very much powerful when it comes to writing data and to a massive scale. Okay, that's the reason we'll be using Cassandra. And so this brings to closure of two important entities that is required here. We need Kafka to as a data streaming source. We need Cassandra to store data at various levels. Okay. After this, let's see our proposed solution to solve the problem. Let's now dig deeper into the solution. We know what we are trying to achieve here. Let's now understand all the technologies that talk to each other, and this diagram will give us a foundational understanding of what we are about to do in the next few modules. As we discussed, the credit card historical data is stored in Cassandra, right? So whatever model we are using over here, it should read data from Cassandra. And there are two possibilities of library that we can use for training the model. One is scikit-learn, which is very much suited for single machine stuff, but the problem of scikit-learn is it does not scale. Okay, but we'll see that as a separate problem, but in this course we'll use scikit-learn. Okay, maybe in a separate course we'll do for PySpark. Okay, so PySpark is where you can deal with large volumes of data to train the model. Once the model is trained, right, we need to have two phases of deployment. One is the REST interface, where the applications can talk to the model using REST, and we'll use Flask for that. Another is, the transactions coming from Kafka server. So the model will be acting as a consumer to that. It will take the data from there and do the prediction. So whatever is the prediction from any of this interface, the model remains the same. The prediction is written back to a database, probably in the Cassandra, where it is awaiting for the further analysis. Okay, once that is done, which confirms whether the prediction was true or false, right, then the data is synced back with the historical data, and the model is again trained. So there can be two types of model: online learning and offline learning. Okay, if it is online learning, the model can be trained on the differential data. If it is offline learning, the entire data should be used in training the model. Okay, so this is the solution that you want to build in the next 3 modules. I'm so excited. Let's get started with the module 2 after this. Hello everybody, this is Avantik here. Welcome to the second module of our series of credit card fraud detection. Here we'll understand all the things that is required for installation and things to do to get it done. The agenda for this series